Okay, we're looking at mixed exercise 5 from the first year core textbooks. This is on straight line graphs. Okay, so we've got line L, we're given the full equation for line L. Then they talk about line M, which is perpendicular to L and goes through this point here. Okay, so line L, they give us in this form. So if I just add the y over, I can then immediately see that the gradient of line L is 2. M is perpendicular, so the gradient of M, so I'll use subscripts to differentiate between the gradient of L and the gradient of M. So if it's perpendicular, that's going to be a gradient of 1/2, and line M goes through the point 0, 4. So I'm going to use y minus y1 is m times x minus x1. So y, so I've got my y coordinate is 4, my x coordinate is 0, and my gradient is minus 1/2. So I'm just subbing all those values in. So it's y minus my y coordinate is the gradient times x minus my x coordinate. So y minus 4 is minus 1/2 x. So I think the easiest way to give that is in the form y equals mx plus c. It doesn't ask for it in a particular form, so any equivalent form would be fine. You could multiply through by 2 to give all integer coefficients, but there's no need to, so that'd be perfectly fine. Show that the lines L and M intersect at the point 2, 3. Okay, so line L was 2x minus y minus 1 is 0. Assuming we've got part A correct, line M is minus 1/2 x plus 4. So various ways you could do this. I think I would probably just make, well, I've already done this once already, but just to write it out again. I think I would just make y the subject of each of them, and then just put both those equations in x equal to each other. So 2x minus 1 equals minus 1/2 x plus 4. But as I said, there's lots of variations on how you might decide to tackle that. So if I add the 1/2 x over, that's going to be 2.5 x or 5 over 2x. If I add the 1 over, so if I multiply up by 2 and divide by 5, I get x is 2. Bear in mind this is a show that question, so it is what you do want to be really clear that you're not skipping any stages of your working out, because you maybe think they're a bit too obvious. Okay, so I also then just need to show where y comes from, so I might as well use that. So if x is 2, y is 2x minus 1, so y is 3. So therefore, they intersect at 2, 3, which, yep, is what we wanted. Okay, so the line N, so this is a new line, passes through 3, 0 and is parallel to M, and we need to find where L and N cross. Okay, so yeah, just got to make sure we're careful about which one's which. So first of all, let's get the equation of this new line N. So N was parallel to M, and M had a gradient of minus 1/2. So if they're parallel, they've got the same gradient, and this new line N goes through 3, 0. Okay, so y minus my y coordinate is m times x minus my x coordinate. So y is minus 1/2 x plus 3 over 2. Multiplying those brackets out. So there's my equation for n, and I am finding where n and L intersect, and L I was given in the original question. So it's just, so that's, I was still on highlighter, right? So that's the equation of n. L is this one here. So I think I'm probably just going to tackle this in the same way as we did part B, so which was to make y the subject of L. So I add y over, and then so I've got two equations. Both of them have got y as the subject. as I said before, there's lots of variations on how you might solve these simultaneous equations. So if I just make them equal to each other, I've got minus a half x plus 3 over 2 equals 2x minus 1. So I'm going to add the 1 over to the left-hand side. I'm going to add the half x over to the right-hand side. So if I then divide through by 5 over 2, I get x is 1. And then I'm going to go back to this equation to find y. So if x is 1, y is 2 times 1 minus 1. So they intersect at 1, 1. Just double check that was what the question was. Find the coordinates of intersection. We can check our answers. 1, 1, yep, so just so you can check there. Students' homework, okay, so yeah, as long as you convincingly prove that, and then, yeah, that's what we got for part A. Brilliant.